Types of graphs. Grouped data and ungrouped data. Types of graphs. For grouped data, graphs help us to visualize data. There are 4 types of graphs for illustrating the graphical representations of the frequency distribution for grouped data, which is given as under. Number 1 is histogram. Number 2 is frequency polygon. Number 3 is frequency curve. Number 4 is cumulative frequency curve, ogive. Example: these data represent the record high temperatures in Fahrenheit for each of the 50 states. Construct a grouped frequency distribution for the data using 7 classes. Solution: the total number of observations of 50. The lowest and highest value in above example is 100 and 134, respectively. Then find range, which is subtracting 100 from 134 to get 34. After that you will find width by dividing 34 by 7 classes, given in question, which is equal to 4.9. So you can try 5 or 4 to get 7 classes by adding in lowest value in data. Let's say by adding 4 in 100 to get 104 and so on. So in this way you can find class limits. After that you will find class boundaries by subtracting 0.5 in lower limit to get lower boundary, while by adding 0.5 in upper limit to get upper boundary. After that you will add 2 class boundary, then divide it by 2 to get midpoint. After that, how many values will fall in given range of class limits, which will help you to find frequency for every class limits, and tally is optional, but you can also make a column for it. The cumulative frequency is calculated by adding each frequency from a frequency distribution table to the sum of its predecessors. The last value will always be equal to the total for all observations, since all frequencies will already have been added to the previous total. Here is the solution of example. In this way you will calculate class limits, class boundaries, midpoint, frequency, tally and cumulative frequency. Number 1 is histogram. Construct a histogram to represent the data shown for the record high temperatures for each of the 50 states. There are 7 class boundaries of grouped data with width of 5 and total frequency is 20. The class boundaries are given on x-axis while frequency are given on y-axis. You can use class boundaries from lowest to highest, such as 99.5 to 134.5. It is important tip that is you can use class boundaries in capital L shape or reverse to make it 7, such as starting from 99.5 to 134.5. Number 2 is frequency polygon. You can use midpoints, which are calculated by adding upper and lower class boundaries and then divided by 2 to get first midpoint. In this way you can find 7 midpoints. The first midpoint is 102, the second midpoint is 107 and so on. The 7 midpoints are taken on x-axis and frequency is taken on y-axis. After that you can put dot where 102 coincide with 2 till 132 coincide with 1. After that you can draw lines and connect all dots to make curve of frequency polygon. It is important tip that is you are using 8 values in class boundaries for histogram construction, and in frequency polygon you will use 9 values on x-axis. 97 and 137 are not given in table. So, you will subtract 5 from lowest midpoint and add 5 in highest midpoint to get it, and make the curve will touch the x-axis, otherwise your frequency polygon will be incomplete. Number 3 is frequency curve. Using the frequency distribution, construct a frequency curve. For frequency curve you need same histogram, but you can use midpoints instead, class boundaries on x-axis and frequency on y-axis. It is important tip that is you are using 8 values in class boundaries for histogram construction. But for midpoint in frequency curve you will use 9 values on x-axis. The lowest value of midpoint is 102 and highest value of midpoint is 132. The difference is 5 between two midpoints if you add 5 in 102 to get 107 and so on. Thus, you will subtract 5 to get 97 from lowest midpoint while add 5 in highest midpoint to get 137 too. Make 9 value for constructing frequency curve. Number 4 is cumulative frequency curve, ogive. Construct an ogive for the frequency distribution. The first cumulative frequency is 2 because frequency is 2, then add 8 which is second frequency to get 10 and so on till your total frequency which is 50 is your last cumulative frequency. The class boundaries are taken on x-axis while cumulative frequency is taken on y-axis. In left side diagram, first plotting the cumulative frequency for then connect all dots to make ogive for upper bound. You can also make ogive for lower bound by going from bottom to top by adding preceding frequency is 1 to add in 1 to get 2 and so on. The rest of procedure is same for lower bound. Summary of graphs for grouped data. The histogram is a graph that displays the data by using contiguous vertical bars, unless the frequency of a class is 0, of various heights to represent the frequencies of the classes. The class boundaries are taken on x-axis while frequencies are taken on y-axis. The frequency polygon is a graph that displays the data by using lines that connect points plotted for the frequencies at the midpoints of the classes. The frequencies are represented by the heights of the points. The midpoint are taken on x-axis while frequencies are taken on y-axis. When histogram or frequency polygon constructed over class intervals made sufficiently small for larger number of observations, is smoothed and it approaches a continuous curve called as frequency curve. Mathematically, the curve is written by the relation y is equal to fx and has an important property. The midpoints are taken on x-axis while frequencies are taken on y-axis. The ogive is a graph that represents the cumulative frequencies for the classes in a frequency distribution. This type of graph is called as cumulative frequency graph. The cumulative frequency is the sum of frequencies accumulated up to the upper boundary of class in the distribution. The class boundaries are taken on x-axis while cumulative frequencies are taken on y-axis. Notes: by adding two class boundaries by 2 to get midpoints. Cumulative frequency may be up to the upper boundary or up to the lower boundary of class in the distribution. You can just go from top to bottom or bottom to top by adding next frequency. The first frequency will be same in calculating cumulative frequency taken as first value of frequency from either top or bottom for calculating upper than or lower than cumulative frequency, respectively. Types of graphs for ungrouped data. Graphs also help us to visualize ungrouped data. There are 4 types of graphs for illustrating the graphical representations of ungrouped data which is given as under. Number 1 is line graph. Number 2 is bar graph. Number 3 is pictograph. Number 4 is pie chart. Number 5 is Pareto chart. Number 1 is line graph. When you analyze a time series graph, look for a trend or pattern that occurs over the time period. The line graph on left-hand side shows an upward trend of vehicles from 1999 to 2003. In right side graph in which I have used 2 data sets for idea that can be compared on the same graph, also called as compound time series graph. If 2 lines are used, as shown in right side graph. Comma, 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 dot. This graph shows the number of snow shovels sold at a store for 2 seasons. Number 2 is bar graph. Figure 1 is the color of eggs laid during 2-day period in October, while, Figure 2, the color of eggs laid during 2 days period in October and March. So, bar graph in example 2 can help you to compare 2 months' data in days easily. Number 3 is pictograph. In first diagram, the answer is 300 plants are planted in a week, while in diagram 2, the answer is 250 players are participated in football game from 5 countries. Number 4 is pie chart. Here is the example 1 of pie chart without legend, which shows that single peoples are 18%, married peoples are 50%, widowed are only 5% and divorced are 27%. While example 2 is with legend given on right side and only percentages are shown in circle for white, dark brown, blue and light brown, which are 50%, 34%, 8% and percent, respectively. Number 5 is Pareto chart. The table shown here is the average cost per mile for passenger vehicles on state turnpikes. Construct and analyze a Pareto chart for the data. First, arrange data from highest to lowest value. The states' names will be taken on x-axis and cost will be taken on y-axis. The Pareto chart in Figure 1 shows that Florida has the highest cost per mile. The cost is more than twice as high as the cost for Indiana. Summary of graphs for ungrouped data. A line graph, also known as line plot or line chart, is a graph that uses lines to connect individual data points. A line graph displays quantitative values over a specified time interval. Line graph is also called as time series graph, which shows data that occur over a specific period of time. Time is shown on x-axis, while any value in digits will be taken on y-axis. Bar graphs are the pictorial representation of data in the form of vertical or horizontal rectangular bars, where the length of bars are proportional to the measure of data. They are also known as bar charts. Any value is taken on x-axis while frequency is taken on y-axis. Comma, 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 comma. A pictogram is one of the simplest and most popular forms of data visualization out there. Besides making your data look nice, pictograms can make your data more memorable. Visually stacking icons to represent simple data can improve a reader's recall of that data and even their level of engagement with that data. There is no x-axis and y-axis in pictograph. A pie chart is a circle that is divided into sections or wedges according to the percentage of frequencies in each category of the distribution. Pie chart is also called as pie graph. There is no x-axis and y-axis in pie chart. A Pareto chart is a type of bar graph that contains both bars and a line graph, where individual values are represented in descending order by bars, and the cumulative total is represented by the line. It shows frequency of defects and the cumulative impact. Pareto charts are useful to find the defects to prioritize in order to observe the greatest overall improvement. In Pareto chart, countries, cities, provinces, etc. are taken on x-axis, while any value such as costs, prices, expenses, etc. are taken on y-axis. Kindly subscribe my YouTube channel Thesis Helper. Thanks for watching.